Okay guys, we're going to pick up with the Chapter 1 review with problem 21. It says Ken is adding a ribbon border to the edge of the kite. Two sides of the kite measure 9.5 while the other two sides measure 17.8. How much ribbon does he need? And so for this one you would need to have two sides at 9.5 plus two sides at 17.8. And when you combine that, I got 54.6 inches. So what you got? Number 2, write an expression that gives the area of the shaded region. You do not have to evaluate the expression. The diagram is not drawn to scale. Well, what they're wanting you to do is they're wanting you to tell them how to find the area of that region. Well, the entire rectangle is 15, and this section here is 4, so this is 15 minus 4. I know that's 11, and you know that's 11, but they want us to write it as a math problem. This entire region, this entire length is 14. This part is 6. So this is 14 minus 6. So to find the area, you would multiply 14 minus 6 times 15 minus 4. Now, what's the answer going to be if you actually do the math on that? What's 14 minus 6?
8.
What's 15 minus 4? What's 8 times 11? 88 feet squared. Okay, based on the pattern, what is the next figure in the sequence? Okay, what do they do? What's the pattern here? Who can describe the pattern for me? Square, triangle, square, triangle.
Reverse triangle.
Circle.
Square, triangle, reverse triangle, circle.
So what do we think? We think that's one whole set, and this is another whole set. So what do we think would come next?
Square, triangle.
Okay, that's the picture they're looking for right there.
Oh, you just want the next one? I wrote a whole other set.
They just want that one. Name the 4 labeled segments that are skewed to CD. Here's CD. 4 segments that are skewed. There's like 2 of these on this whole set. We did one yesterday. Okay, name them for me. Here we go.
EF.
Okay.
AE.
FH. EG. I'm going to highlight those. BF, AE, EG, and FH.
Honestly, these squares are kind of like an optical illusion. That's what makes them tricky.
Name the 3 segments parallel to EF. There's EF right back there at the back. What's parallel to that?
AB, GH, CD.
Good. 26 says, if EF is 2x minus 12, and FG is 3x minus 15, and the whole thing's 23, find x and then find each part. So 2x minus 12 plus 3x minus 15 is 23. 5x minus 27 is 23. Add the 27. 5x is 50. X is 10. If x is 10, this segment is 8. This segment is 15. Any questions on how to do that problem? FG is 15. EF is 8, X is 10. 27, it says T is the midpoint of SU. Find X and then find ST. Wait, did we do this did I have 2 of these on here?
Really? It's an exact replica?
I think it is. 5X is 25, X is 5. So 9 times 5 is 45. Name the 4 rays shown in the picture. Okay, let's name these rays. What do we have here?
I got ray YZ.
YZ. I'm going to color it as you say it. Y to Z is this one right here. Starts at Y, goes towards Z. YZ. ZV. Starts at Z, go towards V. XY, and then XV. XY and XY and XZ are the same. Those are the only 4. Yeah, those. You live in Salt Lake City, Utah, which has an approximate latitude and longitude of 41 degrees north, 112 degrees west. Your friend lives in Goodwin, Arkansas, with coordinates 35 north, 91 west. You plan to meet halfway between the 2 cities. Find the coordinates of the halfway point. You just use the midpoint formula. Okay?
Do you have a map in here?
No, you.
Well, how... Oh, wait, I should raise my hand. How far is Utah from Arkansas exactly?
I don't really know. But I would think it would be, you'd have to drive for at least a day.
Yowza.
Yeah. Okay, so here we go. 41 plus 35 is...
I did the distance formula.
The distance... they want the coordinates of the midpoint.
You divide by 2 and you got your halfway point?
Mm-hmm.
Okay.
38 degrees north and 101.5 degrees west. That's the location of the halfway point. Describe a real-life example of 2 planes in their intersection. Who can give me an example of 2 planes? I'm not talking about airplanes in their intersection being a crane. That's not what... That 2 pieces of paper intersect, and what happens when 2 pieces of paper intersect? What's their intersection create? A line. Plot these points and find plot these points. Let me get the grid drawn. I don't know that I've left enough room. I might have to do it this way. And it says 9, 11. And that's A. And then it says -3, -5. And that's B. And they want you to find the midpoint. Okay? So the midpoint would be, how would you find the midpoint? What do you do, Tom? Okay, so tell me what that would look like. Okay? So plug your numbers in. Okay, so we get 6 over 2, which is 3, and 6 over 2, which is 3. There's the midpoint. Located at what? 3, 3. We found the midpoint. Now they want you to show that AM is equal to MB. So what are you going to have to do to show that the distance from A to M is the same as from M to B? Distance formula. So I'm going to find the distance from A to M. A is located at 911. M is located at 33. Here we go. Alright, what goes in there? The formula says x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. This is x sub 1, y sub 1, x sub 2, y sub 2. So tell me how to put the numbers in. Three minus, okay. Okay. So I have the square root of negative 6 squared plus, what is that, negative 8 squared? Square root of 36 plus 64, square root of 100, 10. So from A to M is 10. Then you have to find M to B. Okay, so I'm going to do that here. M is at 3, 3. B is at negative 3, negative 5. And I have to find the distance between those two. What do we do there? X sub 1, y sub 1, x sub 2, y sub 2. Okay, who wants to help me with this one? Thank you, Gentry. You were raising your hand, right? You were picking your nose? I don't know what you're doing back there. I thought that meant pick me, pick me, pick me. This one.
Oh, okay.
This one's already completed. Okay, here we go.
Okay, I got you. So, alright, negative 3.
Okay.
3.
Good.
And you go negative 5.
Alright, so this is?
Negative 2, negative 6. Squared plus 5 minus 3.
I get 10 again. Okay. Now they want you to prove that 10 plus 10 is AB. So what do you think you're going to have to do now? You're going to have to find the distance from A to B. 9, 11, negative 3, negative 5. Okay. Gentry, pick someone to help me do this one since you were so gracious to help me do the last one. Thank you, Aaron. I appreciate your help. Come on, I know you know how to do this. Okay. Good. What's this going to be? Negative 12 and negative 16. So this is 144, 256. Somebody check me and be sure it's 256. What are you giving you add them up?
Wow.
20. So, did I prove that this is 10 and this is 10 and the whole thing is 20? Could you do that? Now, if I gave you that problem, would it be fair for this problem to be worth the same amount of points as, say, number 29, where you just find the midpoint? No, it wouldn't be fair for something that required all that to be worth the same amount of points, would it? This would need to be worth like 10 points, and then all your other questions would add up to be 90 points. That would be fair, right? Look at the amount of work you put in.
I'm still working on it.
I know, it's a lot of work. So I want you to be aware of that. So when you have that open response question, that I want you to remember it's worth more points because you have to do more work.
No, literally.
That's just fair. Okay, here we go. We checked that one off our list. Let's talk about 32. if AB, the ray, is opposite of AC, now this is what the picture looks like. There's AB, and there's AC. That's what they've said. AB is opposite AC, and AC is opposite AD. What can you conclude? Well, the question is, where are you going to put D? Because for this to be true. Where do you think D should be? Where does it have to be instead of? No. Could I put it in front of? Could I put it here? Could I put it here? Yes, I could put it either place. This could be named AD or AB. So could this one. When you're naming a ray, it's very important to name the endpoint. And then it doesn't matter which point you name as long as it's going in that direction. It could be A, it could be AD or AB. Could go on out there. If you had something way out there, like let's say X was way out there, you could call it AX. That would all be naming the same ray. Opposite rays mean they go in opposite directions. So D has to be over here somewhere. It can't be over there where C is. Okay. Is that all?
I didn't catch any of that.
Okay. The AB goes this direction, and AC goes this direction, and we want to draw AD so that it's opposite of AC. Right.
Is that all you have to write, or do you have to write all that crap? Wow.
What can you conclude? Ray AB and ray AD are the same.
How are they the same?
They're the same ray. You name a ray with a starting point, and then you give another point telling it which direction it goes.
So if they got the start point, the same start point, they're the same.
If they've got the same starting point and they go in the same direction, they're the same.
So all that stuff on the right, besides the A, what's the A?
Because I said you could name it, if you went way on out here and there was an X, you could also name that ray AX.
So all that stuff on the right is irrelevant. I can get rid of that. I'm thinking like a long, drawn-out paragraph, and then it's like this little stuff, this little point